Okay. Now, some of the services that have to do with reliability is IAM. IAM is one of them. VPC is one of them as well. Trusted Advisor, Shield, CloudTrail, AWS Config, Amazon CloudWatch, auto scaling, AWS CloudFormation, S3 or simple storage service, Glacier, KMS or key management service, among others. But those are the ones that are constantly used when it comes to reliability. Okay, so what's in this module? This module, part one, we're gonna see the principles of the reliability pillar. Okay, part two, making your infrastructure more reliable. We're gonna have an exercise like we always do to improve our architecture. That's the part three. Part four, we're gonna see reliability, pillar questions like we always do. And then the lab was already done by you guys. Okay. Am I right? Do you guys do this lab? Multi-region failover?
Yes.
Yes.
Okay, good. So upon completion of this module, you will be able to describe the ability of a system to recover from infrastructure or service disruptions, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfigurations or transient network issues, right? Okay, so this expression here, this little paragraph here, what's the service that helps you dynamically acquire computer resources? What's that service? That's a question for you guys. What's that service? No answer?
I mean, I feel like that would just be auto scaling.
Yeah, auto scale.
That is correct. That is correct. So that's the one that you dynamically can scale out or scale in to meet the demand. Okay. What is the service that helps you mitigate disruption like misconfigurations?
Load balancer? No.
No, inspector.
Yeah.
Inspector?
Doesn't it inspector?
Oh,
no, misconfigurations. No. That inspector lets us see what's going on.
Which one?
Configs.
That is correct.
Yeah,
AWS config.
Yeah.
Right? That's the one that tells you if there's a change in configuration. Of course, if the change was for the worse or for the good, right? Right. Good. So we're going to identify the design principles and the best practices of the reliability pillar. Okay. So part one, what is reliability? Is the ability of a system to recover from infrastructure or service failures. Okay. Dynamically acquire computer resources to meet demand and mitigate disruptions such as misconfigurations or transient network issues. That's basically what they said here in this paragraph. Okay. So reliability is when you are able to, despite failures, continue working. Okay. Continue being operational. That's reliability. So the services that we spoke about, like, auto scaling, AWS config, CloudTrail, CloudFormation, Shield, KMS, all of them cooperate, they contribute to make a system reliable. Of course, not all systems are the same reliable. You have to, add services, you have to make it reliable. Remember, when you start a system, it begins from scratch, right? Nothing. You're the one that has to have the knowledge and the resources to start adding things to your system. So the more you add, as long as it is functional, is going to make your system reliable. Because It doesn't make sense to add and add and add, and what it does is add complexity and more overhead. You don't need that. You need to keep it as simple as possible, but at the same time, your system has to be reliable. Okay? Now, the foundations, that's very important, right? You have to be able to have strong foundations in your system, right? You start from, like when you build a house, if you don't have strong foundations, when it comes a storm or any climate, catastrophe or something, weather or something, what it happens is it will destroy your house, right? Same thing with the system. Systems, it's like daily life. You have to have strong foundations, right? Your system has to be reliable. When you have you're thinking about high availability, you have to make your system, at least 2 availability zones and at least 1 EC2 per availability zone, right? So that should be the way to start an infrastructure. You should have all the logging, all the logging in place, all the logging capabilities in place. You should have, the security in place, well, like security groups, like Knuckles, like, and put your confidential information, your data, your sensitive data in a private subnet, and only allow a NAT instance or a NAT gateway or any kind of jump box like a Bastion host or these guys that are there in the public subnet to allow internet into the private instances. So you have to have that. You have to have an elastic load balancer, to send head checks to the instances to check if they're operational. You should have another scaling group, right? So we'll scale out scaling depending on the demand, right? You should have these resources should be in place, right? So that's guys, give me a second. Someone's knocking on the door. One moment. I'm back, guys. Sorry about that. Someone knocking on the door, so I had to open the door. So we were here, and I was saying that those services, they have to be there, like the foundation of your system. The goal of reliability is to keep the impact of any type of failure to the smallest area possible, right? And by preparing your system for the worst, like the CEO of CTO of Amazon says that everything fails, right? So you have to architect with failure in mind, right? Thinking that things fail and bad things happen. So you have to be ready for that even before it happens, right? It's not nice to react to a catastrophe or something bad without having a plan before it happens. That's not good at all. And you as an architect, you have to be, mindful of that before it happens, right? You can implement a variety of mitigation strategies for the different components of your infrastructure and applications. Don't forget that reliability focuses on the ability to recover from failures and meet demand in 3 areas: foundations, change management, and failure management. So changes, that's important, right? Well, I think we spoke in this class that your system has to be open to change, right? Because things will change over time. New technologies are emerging, new systems are being created, new versions, updates. So your system has to be able to accept changes, right? Without breaking the rest of the system, right? So you have to think about this too. And failure, of course, when you have to build with failure in mind. That's very important. These three areas is where you have to focus on. These are the areas you have to think about when creating a system, right? And not only when creating a system, when creating a reliable system. So that's very important as an architect, right? So design principles. You have to have some testing recovery procedures, right? That's why you should have some penetration tests every now and then, right? To make your security more secure, if you can say it that way. And then you have to test your system, right? Test your system during development, test your system after development, test your system after in production. So you have to have um, test recovery procedures in place. That's very important. That has to be together with your system. When you create a system, you have to create a testing system as well, right? To be able to test that even before it goes out to the customers. You want to have the best opinion about your system as possible before it gets to the customer. And when it gets to the customer, you want to have good feedback. The better the feedback, the more reputable your company is and your developers are. So you have to be able to automatically recover from failure. These guys that say that your system is global, you can think about Route 53. Route 53, it's a guy that will reroute. When a region is down, it will recover and fail over to another region. When your availability zone is down, your database will fail over to another availability zone. So those are things that you have to think, and that has to be done automatically, not manually. That's not good at all, because you're not going to have time to have people there standing in front of a computer to manually move services from one AZ to another one, or from one region to another region. That doesn't make sense. So the goal here is to make everything automatic, right? And recover from failure. That's very important. You have to be able to scale horizontally, And when I say horizontally, what do we mean? Or what do they mean by horizontally? That's a question for you guys.
Adding the instances, for example.
Yeah, good. Increasing the number of instances, right? Right. And how would you scale a database horizontally? We know that we scale an EC2 using auto scaling, right? Right.
Yeah.
Based on a policy, we just set up a policy and say when the CPU is greater than 80, add 2 more instances. Okay, we know that, from previous lessons. But I've mentioned this before. How do you scale horizontally with databases, with an RDS, for example?
I forgot the name of that, but I know that you replicate data to other availability zone. I think so.
Isn't it that you just create more EC2s?
No, we're talking about databases.
Oh, sorry.
Replication, I think so.
We don't have auto scaling for
read replicas.
Read replicas. That's correct. We don't have the service auto scaling for RDS. We don't have that, right? What we do, what we can do automatically is create read replicas, right? And if we could call it auto scaling, but it's the action, not the service, like we have with EC2, right? So we can scale automatically, adding read replicas, but that's some workarounds that you have to do to be able to scale automatically. But we don't have auto scaling for RDSs, right? And that DynamoDB scales automatically. We don't have to worry about DynamoDB. DynamoDB is a fully managed service, and it scales automatically. Okay, you have to enable auto scaling, right? Don't forget that in DynamoDB, but it scales automatically, right? And we don't have to continue guessing the capacity, right? When we have this guys automatically set up, right? All this automation here, we don't have to continue guessing the capacity or the needs that I have, because it'll fall in place when I have these services automatically, right? So manage change in automation, right? You have to manage the change, whatever change happens, right? You have to be able to work on that while automating your stuff, right? Now, the key services for reliability. So we have in the foundations, right? The foundations, we have IAM. You know that if you don't have this guy in place, you are condemned to be broken one way or another. Okay? This guy has to be there. You know how you have to know that you have to create roles. You have to create roles. You have to have groups. You have to have policies. You have to have um, users. You have to have a lot of things that have to do with IAM. That's super important, right? This guy is the one that gives you access to services, right? Is the one that, let services interact with each other. That's the one. IAM. By creating a role, a Lambda function can access EC2 instances. They can interact with each other, right? By using a role. By you creating users, you give users credentials, and then they can access your account either through the CLI or through the console based on the access that you gave the user, either programmatically or the console. So that's very important, right? With IAM, you can create a role when someone comes as an auditor or an inspector from a third-party company that audits your company every now and then. You can create a temporary role for that person, and the person would assume that role, and then the person can work with different services, right? Based on the role, based on the access that you're giving the person. Okay, you can enforce MFA for all of your users, right? Whenever they access their account, they have to have a second, like a two-step authentication, like MFA, right? Using Google Authenticator or any other authenticator that you guys may want to use. Okay, that's very important. Amazon VPC, you know that most of the services that we use, I would say a big part of the services that we use in AWS, they are VPC based. So they're going to be inside of VPC, and the VPC is very secure because it has a lot of security in place. Like we have spoken before, EC2s, they have to be inside a VPC. RDSs, they have to be inside a VPC. And with them, you can have security groups for both RDSs and EC2 instances. So they have security groups. You can have the NACLs in the subnet level. Then you can have some VPC logs, right? You can have access logs for your Elastic Load Balancer. You can have logging for CloudTrail. You can check your system, all that. You can have Trusted Advisor to give you recommendations on if you have any limits that you are missing, maybe some security, maybe cost optimization, reliability, security, all those aspects. Trusted Advisor can give you a recommendation for that. If it is full Trusted Advisor, which is for the business and enterprise plan, that's going to be even with more benefits and features. You have AWS Shield, that's going to be protecting you for DDoS. DDoS it's a very common way of attacking systems, right? And that's going to be in place. You can also have some WAF there, web application firewall. So those guys come together. They come together and they form the foundations of your system, right? They're going to be there as the foundation of your system. Then the change management, you have CloudTrail there. CloudTrail is the one that's going to tell you who made the change, when the change was made, what time the change was made, everything um, that has to do with, all the API calls and activities in your account. Any change that happens in your account is going to be recorded by CloudTrail. But remember, you have to enable CloudTrail, right? You have to enable it. And you have to enable CloudTrail if it is regional as well, right? So AWS config is the one that has to do with changes in configuration, right? It will give you some reports on that, right? And it would tell you what services are compliant, right? Let's say that some ports are open and they're not supposed to be open. This is the guy that's going to tell you you have some ports based on the rule that you created, because you create rules with AWS config based on the rule, right? That you guys created. This service is compliant or is not compliant. So that's very important, right? Amazon CloudWatch, they'll be monitoring your services, right? The health of your systems, of your services, is going to be telling you if the service it's operational, what's going on, what is the CPU usage, what is the network in, network out, the disk operations, and all the metrics that you guys have heard about. And also you can create custom metrics. Don't forget that CloudWatch has two flavors. It has the enhanced one, the enhanced monitoring, and the basic monitoring. The basic monitoring gives you metrics every 5 minutes, and the enhanced one gives you metrics every 1 minute. And the basic is cheap, is free, and the enhanced one is paid. You have to pay for that. You can go all the way down to 1 second metric reports per second, but then you have to create a that custom way of getting the metrics, right? And that's gonna be if I'm not mistaken, it's gonna be what's the name? A high resolution metric system, high resolution. So it's gonna be 1 second, right? Which is very good, and it's gonna be a little more expensive because you get metrics every 1 second, right? So we have auto scaling. Auto scaling. I mean, guys, I'm kind of repeating myself. Auto scaling is the guy that will dynamically adjust to the demand, right? It's gonna add or remove instances based on the policy that you guys created, either um, either based on a metric or based on any other custom metric, whatever. This guy is going to be um, acting upon that, right? So failure management, cloud formation. You can create cloud formation, resources that will work, against the failure. It will work, to respond to failures, right? Amazon S3, Amazon S3 has backup storage, right? So you can store backups or snapshots of different volumes, EC2 instances, RDSs, and then you can recover for that, right? Amazon Glacier, that you can store Amazon Glacier. It's by default encrypted, whatever you store there, and it's gonna for long lasting, files archiving. In case of something fails, you can retrieve the information from there. Remember that when you retrieve the information from Amazon S3, it's immediate retrieval. But with Amazon Glacier, you have three types of retrieval. You have expedited, you have standard, and then you have bulk. Bulk and expedited is from 1 to 5. It takes from 1 to 5 minutes. Standard, it takes from 3 to 5 hours, and bulk takes from it takes from 5 to 12 hours. So be mindful of that. That's important. And KMS, KMS is for encryption. This is very important as well, to encrypt your data just in case something fails. Your data is encrypted, and you don't have to worry about that. Another way, remember in S3, I think I mentioned this several times. Another way to protect your data in S3 is either with server-side encryption, that you can encrypt your server-side encryption using AES, Advanced Encryption Standard, 256-bit, and also you can enable an MFA delete, MFA delete, and also you can enable versioning, right? Versioning, it's very important when hackers try to access your account. You have another version, so if they take the original one, you still have a version, you still keep the file, right? And that's very important. MFA delete is very important because the person we have to, like a second layer of protection, the person we have to authenticate or confirm a second time if they want to delete a file. And this is important to avoid accidental deletion. So that's very important. Okay. So making your infrastructure reliable, a disaster recovery in AWS. Example, architectural patterns sorted from highest to lowest RTO and RPO. We spoke about RTO and RPO before. Backup and restore, pilot light, fully working low capacity standby, and multi-site active. These are 4 different ways to work with disaster recovery in AWS, right? So the first, we have here a diagram, right? So in this diagram, we have a traditional server, right? Then in this, the data is in the traditional data center. That's server, I'm sorry. That's where the data is. So Amazon Route 53 points to the data center, right? It's right here, right? And it copies data either by using AWS Snowball or directly into an Amazon S3, right? Sorry. Yeah. So this is how it works here. So this is on premises, and this is the cloud, right? So we're using here Snowball. Snowball is a service to transfer data from the on-premises to the cloud. So, and this is basically, have you ever seen a Snowball, guys? Never?
Was a fire top.
Like a snowball in real life?
It's like a device. It's a device.
It's a
for
big
transfer
briefcase. It's a big briefcase looking thing, yeah.
data. Mm-hmm.
Oh, I thought you were talking about like a real, like an actual snowball. Like I thought that was a joke, like sarcasm.
No.
No,
No,
yeah,
no.
it's like a
Maybe
big briefcase that holds a lot. It has a lot of storage.
Uh-huh.
Right. No. Maybe I didn't word my question right. Of course, you've seen a Snowball, but I was talking about the Snowball, the briefcase that Amazon AWS uses to transfer the data, right? So it's just sent to the data center, right? They install the Snowball agent, right? And they put all the data here, right? And this will work in the petabyte scale. You see, petabyte scale. It's a lot of data, right? I was watching. I think I was watching. I think it was my solutions architect course in a Cloud Guru, because I use a Cloud Guru as well for my solutions architect associate certification. And the guy, he used a Snowball for only 1 file. And that's absolutely crazy. You're spending so much. This is expensive, guys. That's expensive, right? And he wanted, for the sake of demonstrating how to use Snowball, he used this service for only 1 file, which is crazy, right? Because this is when you have petabytes of files, of data. Okay.
Yeah, that's crazy for 1 file.
Yeah. And this is in the family of Snow. They also have Snowmobile, which is a truck.
Trailer.
A truck. You see?
Mm-hmm.
Okay. I think this is in the exabyte. Let me see here. Snowmobile. So exabyte scale. So this is these services in the family of the snow, snowball, snowmobile, it depends on how much data you are moving from one place to the other, right? But this is literally a truck, as you can see here. That's a truck. It's not like a snowball, which is a briefcase. This is a truck that AWS, sends to get the data from your data center. And it's a good thing because with Snowmobile, you can work with the data while in transit. Okay, so if you have to make some changes to the data while it's being transferred from on-premises to the AWS cloud, you can still work on that. You can edit the data. Whereas with Snowball, there's nothing you can do because the data has been transferred in a briefcase. So, and also because that service doesn't have that capability to work on the data while it's being transferred. Okay. But this one is expensive as hell because you're moving a whole truck of data, and also you have to pay for whatever shipping, or gas or diesel, whatever it is, that should be included in the service. You're paying for that, right? You're paying for everything, right? They may not tell you, well, you have to pay such and such for diesel. No, that's included in the price already. They don't have to disclose that to you or break that down. No, it's not relevant, right? So, when moving this, right? Moving this, okay. Route 53 here, just in case it is, global. We are in the global, global air dimension. And that this guy is the expert in storing backups. Okay, that's the preferable way, the preferred place for backups because it's durable. Don't forget that it has an 11 nines durability, right? And it has 99.9 availability, right? So remember that S3 will replicate your data automatically in 3 different AZs. So that's why S3 is so reliable and so widely used. Okay, so you can store the backup there and restore it from that backup, right? So here we have how you would restore the system using the backup and restore method, right? By the way, this is a method, right? Backup and restore. That's one of the methods. We spoke about here about 4 different backups methods. This is one, backup and restore, right? So what happens in this scenario? You should already have an Amazon machine image, right? And then you can use that AMI to provision an instance, right? So that's very important because remember, the AMI is the software that contains everything that you need for an instance, right? It's an image that contains the software, the operating system, all the updates, everything that you need that's going to be inside that EC2 instances when you create it, right? So after you provision the instance, what happens? You can then copy the data over from your Amazon S3, and then you can switch Amazon Route 53 to point to your site in AWS, right? So you can save everything inside the Amazon S3. So you can copy the data from there and have Amazon Route 53 to move to that data. So you can change probably the DNS. That's where the services are going to be accessed, and then Amazon Route 53 will reroute everything to that particular site where your services are. Okay, so for this backup and restore, things that you have to have in place is an AMI. Okay, so you have to have that in place so that you can restore or create your instances from this AMI, right? And how do you make a copy of the AMI? I think, guys, you know that, right?
Create a copy.
Oh my God. I have to authenticate. You know that's a little annoying, but it's super secure, right? By the way, we did this on Friday, right? Before the class was ended, we created MFA for some of the students that were on that time. So I don't have any C2 instances, I guess. And then I will have to create one a little quick here. I don't care about the, you know, of course I have to care about the image, but I can just launch here and not use a key because I'm not SSHing in any instances. For this one, for example. So this one is the image here, you see, right? So where it says image here, I can create an image, right? And then I can just name it, right? I can say image name, my first image, right? Image description, this is an AMI of my US East one currently running instance, right? So it has the same, I can change this if I want to, but if I want to create an exactly instance, then I can come here to what it says my AMIs, and then I see my first image here that has been created for me, right? So I can save this like this suggests in an Amazon S3 bucket. So I can, from this image, I can restore that, right? And instead of, for example, when I create another EC2 instance, right? So I come here to the EC2 instance dashboard. I click on launch an instance, and then I can choose my AMIs. It's not active yet because still created it. So, but when it's created, I can choose it from there, right? You're still pending, right? And it's private. It's for me. It's private, right? So this is region specific, right? This is specific for this region, the one that it was created in. If I want, I can share this with someone else, but that person will have to make a copy of this, right? It will have to make a copy of this. And also, there's something called a byproduct. If I purchase an instance that is reserved, right? Or an instance that I owe money on, and I share this instance with someone, I cannot share it to another region because there's still money owed in that particular instance. So what the person will have to do is make a copy of that image, and the image will be his, right? But in the meantime, I cannot transfer ownership of the image because there's money that is owed on this image, for example. Now, if I come here and launch an instance, let me see if I can use my AMI here. No. Well, I can launch an instance right here from this image, right? And it will go straight to the second page. Remember, the first page is choose the AMI, right here, choose AMI. It goes straight to the second one because the AMI is already included. But if I launch an instance from zero, from scratch here, and then I have to choose an AMI, I could come here and I could select the one that I just created, right? My first image, and then it goes on to continue the instance. So I'm gonna create exactly the same instance with the same software, the same operating system, the same skeleton. Everything's gonna be the same. Unless in the middle of the process, I change things. For example, here, I can come here and select this, and then I continue. I can change the type. Then I'm changing the instance, right? But if I just launch it like this, it's gonna be exactly the same. It's gonna use the default security group, the default size. The instance is gonna be the free tier. the type, right? Or I can make changes here. I can request a spot instances. It's going to tell me the price. I can add this instance to a placement group, right? In the placement group, again, I don't have any placement group. We have to create one, right? I can have change the shutdown behavior. I can create a role. I can add some user data, right? Some scripting here, Bootstrap script. But if you just go ahead and review and launch, it's going to be exactly the same as the other one. Okay, so that has to be in place when using the backup and restore method, right? You should have there, right? So the AMI is the one that has the pre-bundle with OS and applications. It has everything that you need to create an instance, right? So the data copy from the object in the bucket. You can use that using Route 53 to switch. Route 53 is the one that points to different services, different regions, all that. So you will have to make a tweak in the DNS where the services are going to be accessed from. Backup and restore, it has some advantages. It's simple to get started. You only need whatever we saw here. It's simple to get started. It's extremely cost effective, mostly backup storage. That's what you have to pay for, mostly this. And then maybe if you're using Route 53, you have to pay, whatever price this is. But, believe me, it's not expensive because you can ask Brian. Brian, are you using Route 53 as well in your architecture?
Yes.
Okay, how much are you paying monthly?
I mean, I don't really pay much at all. Like, I think I pay like 60 cents. I mean, for Route 53 and buying the domain, that's like $12 a year. But besides that, like 56 cents a month, something like that. And that's including, S3, CloudFront, Route 53, and I think the certificate manager.
Yeah, good. So that makes AWS a choice that is very cheap, and it's a very good source to consider when it comes to cost. That's why it's so extremely cost effective. So you have a preparation phase. You have to take backups of your current systems. That's something that you have to put in place, guys. It's something that you have to have either manual or automatic backups. Okay. You have to have that in place. It is highly recommended to backup your systems every day. That's very important. The more frequently you backup your system, the more data you will preserve. Okay, of course, the more frequent, I can say that too. The more frequently you backup your data, the more you're gonna pay, right? But that's important. Okay, that's important. You don't pay for backing up your data, you pay for storing your backups. Okay, so the more backups you have, the more storage you would need in S3. Okay, so you store the backups in S3, you say it's durable, it's highly available, it's very reliable, right? Amazon S3. You have to describe procedures to restore from backup on AWS, know which AMI to use, build your own as needed, and that's what we did. We built our own, and this is a custom AMI. Okay, you can get it from the marketplace, right? And by the way, this is where you get the NAT instance from, right? So if you enter here, see, where's the word NAT? Okay, let me see here. Okay. Right here. This is a NAT instance, right? This is already built in. It's built for you guys. It's an instance that has VPC here, you know, and it has an AMI here as well. So this is a guide that you will use to work with your private subnets. Okay. It's already created for you guys. You have several NAT instances here. This is where you get it from, right? From the community AMIs. You can have different operating systems here. If I want all the Linux ones, they're here. If I want the CentOS here, maybe you want to have a Windows one, it's already here. Or maybe you want to have an Ubuntu one, it's already here, or Red Hat, you know, if it is 32-bit, 64-bit, 64-bit, you know, the root device type, if it is an instance store, remember instance store, whenever you delete the instance, the storage will disappear, right? So EBS backed instances are more secure, right? Because you can take a snapshot of this guy, right? Or keep it if you don't enable it, if you don't enable keeping the volume, it will be also deleted when you delete your instance, right? But you can enable it to be kept after that. Also with CloudFormation, when you create resources with CloudFormation, you can keep resources when you delete the stack. So that's very important. Okay. So you have to know how to restore systems. You have to, from the backups, you have to put a strategy in place. You have to know how to switch to the new system. You know what we've spoke about with Route 53. You know, you will switch the Amazon Route 53 to point to your new site in AWS. And you know how to configure the deployment. You know, if you're using probably blue-green deployment, you have to know how to use that with Route 53 or with Lasty load balancer or with cold deploy, you know, if you're using canary deployment, you know, like I explained to you guys before. So you have to have that in you know, in place to be prepared to use this method before something happens, something bad happens. In case of disaster, retrieve backups from Amazon S3. We know that already. Boot up require infrastructure. Amazon EC2 instances with prepared AMIs, elastic load balancing, etc. Use AWS CloudFormation to automate deployment or core networking. Recently, Amazon, AWS enabled this deployment, automatic deployment with CloudFormation. Before it was not possible. Now CloudFormation can be used for deployment automatically. Okay. And that can be used by using the code pipeline, you know, in using cloud commit, cloud build, cloud deploy, you know, and then you can use CloudFormation as in the deployment stage, right? You can restore system from backup, right? Once you have the backups from the Amazon S3, you can restore that, switch over to the new system, adjust the DNS records, right? That in Route 53, right? Because remember that when you switch to another site, it's going to have a different DNS. In other words, it's going to have a different IP address. So you have to work on that, right? And it will point to AWS. So objectives, RTO, as long as it takes to bring up infrastructure, restore systems from backups, and time since the last backup. So all of this, guys, have to be, you know, thought out and, you know, thought of when you are preparing for disaster recovery in AWS, right? Using this method here, backup and restore. So key points here, have your AMI ready for restoring your instances, right? That's for the instance. You're still not complete because you have to have your data, right? If you use an AMI with an EBS volume and you create an EC2 instances, an EC2 instance, you still don't have the data because the data is backed up in Amazon S3, right? So you have to retrieve this data and then use it, right? This is gonna be a snapshot, right? or a backup, and then you restore that snapshot or backup, create a volume, and then you attach the volume to an EC2 instance, and whoop, there you go. You have the instance running again with the same data. So that's very important, right? Pilot Lite. So Pilot Lite, there's another one which is a little more expensive than backup and restore. Okay, so in this architecture, you have an on-premise system. It's right here, right? The on-premise system is right there, right? Now, Amazon Route 53 is pointing you to your on-premises. You have it here, right? It's pointed to your on-premises, right? It's right here, pointing. Now, you have a smaller database instance. It's right here, right? A smaller database instance in the cloud. And when you mirror the data or replicate the data from your on-premises system, okay, you have two servers that represent the web tier and your application tier. It's right here, right? But they're not on and they're not running, okay? So you have the data here, data volume here, right? Smaller instance, and then the data is being replicated to a data volume, okay, in your on-premises, okay? So this is an overview of how you're going to establish this method, right? So now, if the primary system fails, right? If the primary system fails, you grow your database server, right, to the size that it needs to be to take on the production data traffic. And then next, you turn on the web browser, an application server. Oh my God, one moment. Server, and then you point Amazon Route 53 to your new servers. The entire process can take minutes, okay? So if we go here, let me see here. So the idea of this Pilot Lite is an analogy that comes from the gas heating. In that scenario, a small flame that's always on can quickly ignite the entire furnace to heat up a house. In this DR approach, disaster recovery approach, you simply replicate part of your IT structure for a limited set of core services so that the AWS cloud environment seamlessly takes over in the event of a disaster. This happens here, and then these guys will take over, okay? You see, well, so a small part of your infrastructure is always running in simultaneously syncing mutable data as database or documents. A database here, right? This is on, it's running, right? While other parts of your infrastructure are switched off. It's right here, they're switched off, they're not running, right? Your database is constantly being replicated and mirrored here. And used only during testing. Unlike a backup and recovery approach, you must ensure that your most critical core elements are already configured and running in AWS, the Pilot Lite. When the time comes for recovery, you can rapidly provision a full-scale production environment around the critical core. So when the time comes, this is the time now, this is down, right? You can provision this real quick, right? And then continue running, and it would take minutes, right? So this is how the Pilot Lite works. It's like a pilot. It's like something that it's been tested, you know, here, this is working all the time, right? working, working, working. This is working too, right? Replicating data, replicating data. Now, when the whole thing goes down, everything continues the same, but whatever was here, it fell over to this one, right? Fell over to this one. This is a little more, pricing than the other one.
Is this for on-premise to cloud services, disaster recovery?
Correct. This is on premises, right? This is for hybrid architectures, the pilot line. Okay. This is always on, running here, as well as this one, always run, because the data has to be replicated here. Just in case the data has to be there, just in case this goes down, it can use these two servers here and use the data. But the data is being replicated to that one all the time, right? All the time. This one goes off, and then it continues working here because the data was never stale. It was always been updated based on whatever was here, and then you can use this guy. Amazon Route 53 will change the DNS from here to here. It was here before. The DNS was pointed to this. The records that were created in Route 53, they were pointed to this on-premises architecture. But then when everything goes down, it points to this one. Okay, does it make sense, guys? Makes sense, right?
So Route 53, it's not only routing, but also understands that the on-premise system is down, for example, or something happened and it doesn't have connection.
Yeah, remember that Route 53 has health checks as well.
Mm-hmm.
Yeah, so if we come here and we go to Route 53, I have a hosted song here. When I come to this here, if I create a record, so this record here, they don't have a health check because I didn't associate it with the health check, but they have a health check here, right? If I create a record and I just select whatever here, I can create a policy here, maybe weighted here, and I can associate this with health checks, right? And it will be checking whatever health check I have here, predefined that I defined before, and then it will be checking if the servers are operational, right? It send the checks here. You're not working anymore, so I'm gonna change to this guy because the record has to be created already. This record here has to be created, so that Route 53 can automatically point to the new record, to the new site, right? All of this have to be thought out before it happens, right? You have to have on-premise services, and this one here is standby, with this one always on, right? Route 53 already has this record, right? But it's not pointed to that record now. It's pointed to this one. When it goes down, it automatically points to this one because this one is not working anymore, okay? So we can say that Amazon Route 53 is like a giant elastic load balancer, similar, right? But what it does is routing based on the records, okay? Based on the records, okay? But it would say that, it's probably the elastic load balancer's dad, probably, the dad of elastic load balancer, but with more features because it's the father, right? More features than the child, right? Different functions, but they're pretty similar because they're both routing, right? So advantages of, very cost effective compared to other ones, right? It uses fewer 24/7 resources. It takes backups of current systems, store backups in S3, describe procedures and restore. You have to know which AMI, the same thing as the other one. Okay, same thing here. You have to know the AMI, which one to use. You have to know how to restore the systems from the backups. You have to switch to new services, and you have to know to configure the deployment, right? So that's pilot backup. You see a difference, guys, between this one, the backup store, and the pilot, right? So in case of disaster, automatically bring up resources around the replicated core data set, scale the system as needed to handle current production traffic. In this case, we have 2 servers. You may have more, right? Depending on your need and capacity needs, Switch over to the new system. Whenever there is a AWS Amazon Route 53, there has to be a switch in the DNS, okay, to switch it to the new site. RTO and RPO, same thing. Okay.
What is this RTO, RPO? I don't remember.
Recover time objective, and recover point objective. Okay?
What does that mean?
Okay, so this is recover time objective and recover point are 2 key metrics that can organization might use consider in order to develop an appropriate disaster recovery. Let me see here. So RTO is what? How quickly you can recover your infrastructure and servers following a disaster. Okay. So this one has to do with the time. How long does it take for you to recover, right? Of course, the smallest the time, the more expensive it's going to be, right? And RPO, what it does, it works with how much data you are able to lose, right? So it's a measurement of maximum tolerable amount of data that you can lose. Okay, how much data can you lose in a disaster, in the event in a disaster? Right. So RTO has to do with how quickly you can recover, right? How quickly you can recover a time objective. The longest the time, the cheaper it is. The opposite is also true. The shorter the time, the more expensive. And this is recover point objective. It has to do with how much data you can lose. Does that answer your question, Maria?
Yes, thank you. I have never seen these terms before.
Okay. So fully working low capacity standby. Okay. Why fully working? You see these guys are, constantly working. You see both. Okay. In the pilot light, there was only one section working, the one on premises, right? In this guy here, we have everything working. Right? Is fully working. Okay. So here, a low capacity standby architecture is like the next level of the pilot light architecture, right? Is the next level. Why? Because the next level in the pilot light is only 1/2 of the architecture working, right? And here is the entire thing working. Okay? That's the next level. So you have to run in such systems, right? Sorry that this happens. It's my mouth. When I move from one side to the other, it moves my slides. Okay, so you have two running systems. The main system and low capacity system. This is the main system, right? And this is the low capacity system, right? You can use Amazon Route 53. And of course, this is running in the on-premises and this is running in the cloud, right? You can use Route 53 to distribute requests between the main system and the cloud system. As you can see here, right? As you can see here, this guy is pointing to both. So you have two records, one that is pointing to the on-premises and one that is pointing to the cloud. And of course, this is more expensive than Pilot Lite, right? Because Pilot Lite is just a half of this, right? So you have a hosted zone, like I do here, right? I have a hosted zone here, right here. This is my hosted zone, which is the website, or the website of your system, right? And inside the website, your system, you have records. So I can have a record pointing to this IP address, right? and I can have a record pointing to this IP address. Okay? So if one breaks, what happens? Due to the health check system that this Amazon Route 53 has, it would not send traffic to this one anymore, and it will just focus on this one, right? Focus on this one. So in an actual catastrophic event takes over your on-premises infrastructure, right? If the catastrophe takes over this, what happens is you only need to change the DNS, right? The DNS to the records to point the one in the cloud. Then your capacity can grow, right? It can grow, it can grow by using horizontal scaling or vertical scaling, depending on whatever you need. In this case, Amazon Route 53 switches over to the second system, which is designed to automatically scale up its capacity if there is a failover from the primary system, right? So in other words, this is failover. What is the routing policy that Amazon Route 53 will use for this? Remember, did I speak about the 7 routing policies of Route 53 in this class? No?
Yes.
Yes? So what is the routing policy that Amazon Route 53 will use here? Do you guys remember, by any chance, do you remember any routing policy of Route 53? No? Yes?
I remember it was like low latency.
No, not low latency.
Geo proximity, geolocation.
Right.
Yeah.
It's not low latency, it's latency. Latency based is a latency, latency based routing policy. Okay? Yeah. This one is failover. Okay? There's one policy called failover routing policy, right? So it will use that one, the failover one, and we'll move one system to the other. It fails over to the new system. And the capacity will grow. This is low capacity because it's what the capacity that you're using right now. Remember that you have 2 systems working, you don't need more capacity, right? You have 2 systems working at the same time. It's like 2 availability zones working, you have the capacity that you need, right? But if something goes wrong, you would need more capacity. Because right now you don't have 6 servers working, you have only 3. So you probably have to double that, right? Double that to be at full capacity again, right? So that's how it works, and it is constantly replicating the data and the database both ways, right? Constantly replicating that. If someone, if this database is written on, this one is going to be updated, right? Or vice versa. Right? The advantages of the full working low capacity standby. You can take some production traffic at any time. That's right? Because you have 2 systems working. It's cost savings if IT footprint smaller than full disaster recovery, right? The preparation, similar to Pilot Lite, all necessary components running 24/7. Of course, everything is running, but not scale for production traffic until something happens, right? Best practice, continue testing, right? Trickle a statistic subset of production traffic to, disaster recovery site. It's good to test this, right? This section here all the time, right? You don't have to wait until this happens, guys. You don't have to wait until this happens. You can't wait until this happens. This is best practice is test this all the time. So when this disaster happens, you can be confident that Route 53 will move this to this site and this site will take over. They fail over. Okay? So that's very important. Very important. In case of disaster, immediately fail over most critical production load. Adjust the DNS records to point to AWS. Auto scale the system further to handle all production loads. Of course, you have to have auto scaling here. Auto scaling has to work with Route 53. They have to be working here, right? To be able to auto scale. Now, you know, let's say that you have 6 or 9 or 12 servers running here, and then you have 12 here. Can you imagine if you have to come here and manually provide 9 more? I mean, that's time that you can employ on something else. So it's good to have auto scaling here. So it will create 9 more servers for you, because 9, I mean, all of these 12 ones, I mean, the 12 servers here are down. So you will need 9 more here. Okay, that's very important. Preparation is similar to Pilot Lite. All necessary components running 24/7 by NASCO. Best practice, trickle statistical. Well, we read that already. Right? So objectives, the RTO and RPO. For critical load as long as it takes to fail over. For all other load as long as it takes to scale further. So remember, RTO is the time that you can quickly recover. Okay, that's the time. And RPO, it has to do with the data that you have to, I mean, you're willing to lose. It depends on the replication type. If it is asynchronous or synchronous. So you have to be how you're doing that. Multi-site active. What happens here? So you have a full-size production capable infrastructure with the AWS cloud. In this case, all of the servers are already operating at full capacity. Remember that in this guide, you were operating here low capacity, right? Now you are operating here at full capacity, right? Sorry. So, and can take the load at any time. You also perform data mirroring and replication between the two sites. So we have here advantage, can take all the production load at any time. The fully working low capacity, it says, can take some production traffic. This one can take all the production load at any time. Production, you know, guys, production is when the system is out there, right? With the users already using your system. That's production, right? Preparation, similar to low capacity standby, fully scaling in and out with production load. In case of disaster, immediately fail over all production load. Okay, they're pretty similar. I mean, the low capacity and the full capacity, they're pretty similar. But the problem is that if this fails with a low capacity, then you will have to scale here. Okay, because it's low capacity, you have to grow. With this one, you don't have the critical need of scaling that because you're working at full capacity, right? Like it's showing there. The graphic is almost the same. I would say it's the same, but one is low capacity and the other one is full capacity. Okay. So RTO, as long as it takes to fail over, depends on replication type. That's the RPO. Best practices for being prepared. Start simple and work your way up. That's the way it is, guys, with everything. Even with IAM, start creating users, and then you start giving access based on the need that arises in the job, right? So you start simple, and then you start adding. Don't start something complicated. You know, more complexity is more overhead, and it's more problems for the people following you or the people that are trying to work with the system that's being created. So keep it simple, KISS, KISS, keep it simple, students, and then, you know, work your way up, right? Backups in AWS as a first step, that's very important. Incrementally improve RTO or RPO as a continuous effort. So that is something that you have to agree with the owner of the company to see how much data they can lose for the RPO and how much or how quickly they want to be back up and running. That's for RTO. That, you know, it incurs charges and cost. So you have to, you know, work this out with the company owner or the person that the CEO, the CTO, whoever is in charge, and you as an architect have to agree on that. Okay, you have to check for any software licensing issues. Sometimes you're using, like, for example, if it is a dedicated host, you will have to bring your own license. Usually when you have Windows servers, they might need a license as well. So that's something that you have to consider as well. Exercise your disaster recovery solution. Practice game day exercises. Remember, game day is like you simulate a real life situation, and then you have to find solutions, right? Ensure backups, snapshots, AMIs, etc. are working. Make sure that the backups are fully operational. They have the data that it was intended to have. The snapshots are properly taken, and monitor your infrastructure using CloudWatch and all of these guys. All this have to be, constantly moving for when the time comes, if it comes, you can be ready for that. Okay, so that's extremely important. Advantages of disaster recovery with AWS: various building blocks available. We spoke about the building blocks before. Fine control over cost versus RTO or RPO trade-offs. That's, cost is very important all the time. So you have to see how much this is going to cost, right? What is the compensation with this? How you can compensate all the stuff to be able to, cope with the cost and all that. You have to have the ability to easily and effectively test your disaster plan. Okay? You just don't put your disaster plan in place. You have to test it. I have said that several times in this class today. You have to test it before it happens. Guys, you have to test that. If you get to work for a company as a solution architect or as a, DevOps engineer or a cloud engineer, and you have to work with disaster recovery plans, guys, you have to make sure that that works properly before something happens, because you don't want to lose your job, guys. You don't want to lose your jobs. You don't want to be in a situation when a disaster happens and your plan doesn't work. Okay, you can easily lose your job. Some business owners have a zero tolerance policy that if something is messed up, you lose your job. There's no second opportunities. Okay, that's very important, because if they lose data and lose money, it is on them. That's their money, their data. You're just an employee, right? You're not indispensable. Nobody is indispensable. I'm not indispensable. I can be as good as it gets, but if I don't do my job right, I can lose it easily, very easily, and someone will take my place.
Professor, this is talking about something like this Amazon Workspaces. Can you talk about that?
A workspace is similar to a desktop.
Mm-hmm.
See, it's desktop as a service. Right here. Where did I see that? Right here. Okay, it's a desktop as a service. You can have a desktop in the cloud. It's like having a computer in the cloud. Okay, so you can use Amazon Workspaces to provision either Windows or Linux desktops in just a few minutes and quickly scale to provide thousands of desktops to workers across the globe. So it's like a platform similar to a desktop that AWS provides, either for Windows or Linux. You can pay either monthly or hourly just for workspaces you launch, which helps you save money when compared to traditional desktops and on-premises VDI solution. VDI, I don't know what VDI is, guys. A virtual desktop infrastructure. Okay, is defined as the hosting of desktop environments on a central server It is a form of desktop virtualization as the specific desktop images run within virtual machines and are delivered to end clients over the network. So going back to this. So Amazon Workspaces helps you eliminate the complexity of managing hardware inventory, OS versions and patches, and virtual desktop infrastructures. We saw that already, which helps simplify your desktop delivery strategy. With Amazon Workspaces, your users get a fast, responsive desktop of their choice that they can access anywhere, anytime, from any supporting device. So it's a virtual desktop. That's what it is. Okay, we'll click on this. I've never worked with this, but I saw a student that was, inquisitive enough to create a workspace in his computer. You can easily launch a workspace for an individual or small group of cloud-based computer in less than 20 minutes. Okay, you have here standard with Windows 10 is included in the free tier. Value Windows 10, free tier. Windows 10, free tier. Linux, of course, have to be in the free tier. Okay. So you can create launch, you have to enter the users that you created, remember? The users that you can create in IAM or create additional users here. Remember the user in IAM, username, password, all that. So basically you are providing a virtual desktop for your users in one single stop, right? One single stop. Instead of using their computers, the desktops, they can use one desktop in the cloud, and they can work like it is a computer. Okay, and then you have more control, right? I mean, you as the owner have more control, right? Does that answer your question, Maria?
I'm still thinking, what is the purpose of this? Why do I want to do this?
Okay. I think we're ready here.
I'll look at, I'm on that page. I'm going to look at the video and see.
You see?
Eliminate
the
I'm not
complexity.
looking at your highlight. I'm managing. I see. But you still have hardware. How are you going to access the machine if you don't have hardware?
Oh, no, you have to use your computer.
Exactly. So
Yeah, but you're not using the desktop of your computer. You're using a virtual desktop.
So yeah, but what would be the use case? So if I have a Windows 10 machine, right? And I can install a Linux, or I can install a Raspberry Pi, for example. Or I can do many things on a Windows 10 that I can create a virtual machine on it. So why?
Wait, this is highly available and scalable. It's in the cloud. Okay. So you can say here, for example,
it must be a use case. Why?
It's Amazon Workspaces is deployed within an Amazon Virtual Private Network. Provide each user with access to persistent encrypted storage volumes in the AWS cloud and integrate with AWS key management service. You cannot have that with your desktop. Okay. No user data is stored on the local device. This helps improve the security of your user data and reduces your overall risk of surface area.
Okay, so
Amazon
it's basically having a computer on the cloud that you access with all the same capacities as a computer, but you're on the cloud.
Yeah, but don't forget that it's 2 instances of a computer too. This is
but this is more like a desktop computer.
This is
right? Correct?
Yeah, the virtual desktop. Correct. It does everything that a desktop does. Right? It says here, Amazon Workspaces is available in 13 AWS regions. You see how available it is, how highly available, and provides access to high performance cloud desktops wherever your teams get work done. You can manage a global deployment of many thousands of workspaces from the AWS console, and you can rapidly provision and deprovision desktops as the needs of your workforce change. So this is highly available, highly scalable. Now, when you have this in a centralized AWS account, you have more control.
So what is the pricing structure for this? Can you click on pricing?
Yeah.
Basically, you can take your PC anywhere in the world.
Correct. And you
But I
don't,
can do that right now. I can
Yeah.
take my computer with me.
yeah, but let's say,
Yeah.
let's say
You
that
don't
you
have
are,
to carry your bags and laptops and anything.
but Maria, what if you're having an hotel and you want to use the computer, the hotel computer? You're not gonna have your desktop there, but you have it in here. So you can have your desktop wherever
Wait,
you
oh,
go.
you went too far. Can you go down? Go down. Go down.
Yeah.
Go down. Right here. CPU.
So one virtual CPU, 2 gigabytes of memory, root volume 80 gigabytes, user volume 10 gigabytes, $21 a month, which is $7 25 months plus 17 cents an hour.
What is for 1 terabyte?
Huh?
What is for 1 terabyte?
1 terabyte?
Uh-huh.
Well, then you have to do some math there. It doesn't say here. Okay. So let's say I'm using
So
someone else.
you will have to add volumes to it, right? You can add volumes to this computer, right?
Yeah. So let's say that I want to use an ANS computer. If I use an ANS physical computer, I can only access an ANS desktop, right? But I can use an ANS computer and access my virtual desktop, which is in the cloud, in my AWS account, right? Or the company's AWS account. So
Right.
that's an advantage, right? That's an advantage. I don't have to have my own physical computer because my desktop is in the cloud. And it's so highly available that I can have it in 13 regions, right? So that's the advantage of the workspace compared to a traditional desktop in a computer. Okay. Of course, apart from that, you have all the benefits that the cloud has, all the benefits, all this control security that the cloud has. That's mainly the huge advantage over traditional desktops. So you have more control. You have all your employees signing in your account, right? Your account in one stop right there in your account. Otherwise, if you have a bunch of computers and they have their own desktop, you have to have a network of computers, and it's less centrally managed. Like it is one account, and everyone inside the account, you have up to, I don't know, it says like up to 1,000 desktops. See here? It said a number, some name, many thousands. So you have many thousand workspaces in your account. That's incredible advantageous. You can provision or deprovision. So scaling, it's there. It's amazing, right? So let's say that you have 13 employees and you have 13 computers. So once an employee is fired or the employee just quits, you have one computer that you're not using, right? One computer you're not using. So you have to have another employee or simply use the computer or something else, right? But when you have desktops and one employee is fired or quits, what do? You deprovision. You just scale in, and that's it. Eliminate one desktop, and it's all in the cloud, right? So I think it's advantageous, but it's an extra cost that you have to incur if you create that, right? An extra cost, I'm talking about an extra cost in the cloud, because you don't need to have workspaces. This is optional, right? But if you have workspaces, that's something else that you have to pay for.
You know what? They have a free service now until June 30th.
Mm-hmm.
But it looks like they have a free tier. Interesting. You know what?
Amazon is a world of surprises.
No kidding.
Yeah. So Amazon Workspaces is a fully managed, okay, desktop computing service. Guys, I forgot again. It's time for the break. Let's reconvene at 2:46. Okay, it's 2:36 now. So take a 10 minutes break, and I'll see you back in 10 minutes. Hey guys, we're back. So like we were saying, Amazon Workspaces is a fully managed desktop computing service in the cloud. It's computing. So you should find the Workspaces here. In the compute service is not included here. You see here. End user computing. So this is where you find it. End user computing. Okay. So the key benefits is fully managed. So you don't have to manage anything. You just, create the service, we use the service and that's it. Okay. It's fully managed. Supports multiple devices. You can use either iOS or Android, different devices. Keeps data secure and available. You can choose software and hardware, monthly and hour billing options, a corporate directory integration, and supports tagging. Okay. By the way, guys, I don't know if the company that gave the training last week is having another one this Thursday. I keep you posted and I send you the link if they are having this immersion day again, another immersion day, and if you're still interested, guys. So we're saying improve this architecture. Okay, so your team has finished forklifting an application into the cloud. Due to a previous failure of the system, your CTO requests a well-architected review of the system. Review the sample diagram and ask questions to identify where improvements can be made to increase the reliability of the system. Recommend reliability enhancements in accordance with the well-architected reliability pillar. Okay? This is the diagram. So guys, I want you to work on this. Okay? I want you to discuss among yourselves. I want you to discuss. I'm going to put you in a room and I want you to discuss what kind of architecture do you think that it's, what kind of improvements do you think that they should be done here? Let me take a picture of this diagram. One moment. Okay, let me take a picture of that diagram and let me post it. Okay.
Te llamo.
I'm gonna put it here. Okay. I'm gonna put it in the chat. So I put it in the chat. I'm gonna put you guys in different rooms. One moment. So I'm gonna create the rooms, and guys, you're gonna discuss what possible solutions we can give to that chart. All right? I'm gonna put you in the rooms. Hey, Chris Luces, yes. Gabriel Garcia, Gabriel Prieto, good. Nice. Stanley. So how many illustrative balances do you have here?
2.
2. Are they the same?
No, because this is for app and this is for web.
Okay. So how about the load balancer here? In between here. You don't have anything here?
I don't see where you're pointing.
Oh, right. You're sharing the screen. Okay. So
I'm gonna stop sharing. Is that
in
okay?
AWS, you have both internet-facing load balancer and internal elastic balancer.
Oh, so you're talking about another one here.
You have to have one between the Bastion host and the web server. You have to one there.
Oh, one here, right here, right?
Yes. And then one between the web server and the app server is enough. Right?
And one here.
Yeah. One in between here. Yeah, that's enough. This one we work with all of these guys and all the app servers and the RDSs. Right? That's the internal one because it's facing the services that are inside the VPC. Right? And the other one is facing the internet.
Like that.
Yeah, similar like that. Exactly. Exactly. Okay, so that's pretty similar to what I have.
So this wait before you move on. This elastic elastic load balancer can actually balance the load for both the app and the web.
Correct.
I thought you needed one for each one.
Yeah.
And
But
then
then
this
you need-
one, this elastic load balancer here, it's in between the bastions, either the bastions and the web server,
Okay.
or each one of the bastions and the web servers.
Okay, this for the first one here between the Bastion and the Bastion host
This
and the
one.
web server, right? Between that one, we're gonna have one that faces the internet, right? One faces the internet. And then you're gonna have another one between the web server and the app that is internal. That is to distribute the traffic inside the subnet. You have an internal one and internet facing one. The internet facing is for the web server, right? And the internal is for the app server and the RDSs.
That makes sense.
It makes sense or it doesn't?
Yeah, now it makes, yeah.
Okay. Yeah, you have internet facing ones and you have to distribute the traffic once it's in the subnet. Once the traffic is inside, then you have to distribute that too. So you have another one, which is the internal one.
I was not distributing this here.
Yeah. So let me share my
missing this
screen.
part. Okay.
Let me request. Okay. Stop. Okay, good. So let me share mine. Okay. So the solution that we have here is this one. Okay. You guys missed auto scaling. I don't know if the other teams spoke about auto scaling. Did anyone speak about auto scaling?
Yeah, I mentioned auto scaling when we were talking about it.
So in this subnet auto scaling has desired capacity 1, minimum capacity 1, maximum capacity 1. So we have only one here, only Bastion host, right? So we have here inside the private subnet,
This is a
right?
different configuration. Huh?
Yeah, the private subnet is the entire thing here, right?
Mm-hmm.
So we have two web servers that are getting the traffic from this elastic load balancer, right? That is facing the internet. Now, here we have another one. Once the traffic is in, it has to be distributed to the app servers and the RDSs, right? And then we have this elastic load balancer, which is internal because it's not facing the internet. The elastic load balancer is getting the traffic from the web servers, not the internet, right? So we have another guy, the elastic cache, right? Because you have to make this reliable, right? And fast in terms of performance, right? So whatever data is accessed in this from this master database is going to be cached here, right? So when the customers come again, these servers come again, they don't have to go all the way to the database that just hit the elastic cache, right? Same here in this second availability zone, right? Remember, this guy is standing by. This guy's not working. It's just there. When something happens, right, with this availability zone, then this guy will fail over here. Okay.
So, but the elastic cache, it's for availability, right? For high availability, but you don't necessarily have to have that there.
Performance.
For performance.
Performance. High availability is the number of that. The number is high availability. Performance is speed. It's not number, it's speed. So it means that when they come here, they don't have to go all the way to the database. They come here and get it. It's already cached here. So performance, right? This is for high availability, these two guys here, right? Multi-AZ, right? Multi-AZ. They just have a layer here, a layer for caching. That's performance to make the query faster, right? So that makes your architecture reliable. having a multi-AZ deployment, right? So this is basically it. Let me see here. Let me see if I can see one moment. If I can find here. So you have internet facing versus internal load balancer. Okay. So an internal load balancer routes traffic to your EC2 instances in private subnets, right? The clients must have access to the private subnets. The nodes of an internet-facing load balancer have public IP, right? Therefore, internet-facing load balancers can route requests from clients over the internet, right? So, so this guy here has a public IP. This one doesn't. They still have an IP, right? They still have an IP, which is a static IP, but this one is public IP, public, because it. Remember, what connects one service to the internet is the public IP, right? No public IP, there's no way to connect to the internet, right? So that's what it is. Internet facing, internal. Okay? So if you want to make this more or higher performing, like more highly performing, then you would add some replicas. All right, replicas. Remember, cache, it's for quick queries, right? Quick queries, but that will offload this database, right? This database, right? You need replicas to make it even, more highly performing. Replica to improve the performance, right? But you were pretty close, guys. You were right on point. A few minor details like the scaling, auto scaling here, that has to be there as well. Okay.
Why is the auto scaling?
Where is it?
Yeah, the auto scaling. Why is it in the public subnet?
Because if the Bastion host goes down, you have to have another one. Remember, it's 1, 1, 1. This one goes down, it creates a new one. This one goes down, it creates a new one.
Oh, I see. I see what you're saying.
Yeah.
So you really don't have to have both of them running.
Right. If this availability zone goes down, it creates one here.
Mm-hmm.
Right.
So,
this one
so
is
basically, basically they got rid of one bastion and just created the auto scale group in case the one goes down.
Right.
So okay.
Yeah. Remember, this availability zone will be in standby.
Right.
The standby here, right? You're using this one, right? Just in case this one goes down, this one goes in, because you don't have any Bastion host working here, right? It's just in case something goes down. This guy's not working either. It's not doing anything. It's just a standby, right? If you have a replica, yes, it is working constantly with this one. Replicas will be getting reads all the time, reads and reads and reads. And remember, the replication is asynchronous with replicas. With standby is synchronous. So whatever is written here is gonna show here immediately. It's synchronous, right? So this was gonna be ready for whenever a disaster happens. You have some replicas, asynchronous replication, okay? And they only used for reading, no writes, only reads, right? You can promote your replica to master, and then you can have writes and reads, okay? But don't forget, disaster recovery, multi-AZ, right? High availability. All right. Fail over to this one. Performance, replicas, okay? And that's the way you scale horizontally with RDSs, creating replicas, right? You're not scaling out with this guy. You're just preparing for an event, okay? Something that happens here, it fails over to this one. Okay. Well, like we saw before, this is the solution, right? this is high level, okay? Of course, you have many more things here inside this here. We're gonna have security groups. We're gonna have knuckles, all that. You know, outside we can have some shield, WAF, you know, all outside here, outside the VPC, right? We're gonna have CloudFront working there. You know, we have S3 buckets, CloudFront, API gateway, all those guys. So multi-region failover with Amazon Route 53. I think that's something that you already did in the lab, guys, right? Am I wrong? All right. Who hasn't done the lab, this lab? Who did lab 11 already? Who didn't? Who hasn't? So please give me a thumbs up if you did it.
I took it in the assignments. Is it we have to go into the vocarium?
Yes. Yeah, this is lab 11. It has to do with failover.
No,
Wait.
I haven't done that one. No.
When you do this, when you guys do this, you can understand this lesson better. Okay, because this is the lab about failover, multi-regional failover. Using Route 53, you know, you're gonna create a record, Route 53, right? You're gonna have a hosted zone already created for you guys. Okay. Yeah, you will create a record set. And then you're gonna test your failover strategy. Okay. So you're gonna use Amazon VPC, Amazon EC2, Amazon Route 53 in the lab. You're gonna configure and test a cross-region disaster recovery, failover to another region, inspect resources in 2 regions, create an Amazon Route 53 health check, create an Amazon Route 53 domain, configure primary and secondary settings, and test failover. Okay. Remember, when you have failover, you have to have primary settings and secondary settings. The primary settings is the one working, and the secondary settings is the one in standby. All right. So Route 53, here you're gonna have 2 web apps, right? One in region 1, one in region 2, one is primary and the one secondary. And then Amazon Route 53 is pointing to region 1 through the health checks, right? You know, health check is telling me this one is operational, still operating, right? And then if something happens, what it does is fails over to this one, and it points, the DNS will point to this record here in region 2. Okay. So Route 53 is a super important service for failover, right? And it's gonna use, let me see here. So you have the file that you see.
Like a sniffer, a domain server, a translator.
Yeah, it does a lot of things.
A lot of functions, you know.
Yeah, it resolves the DNS to an IP address. It routes the traffic when one region is down. It's based on routing policies. Here you have the 7 routing policies of Route 53. This is the one that it uses when a region goes down, right? Use when you want to configure active passive failover, okay? In this region, in this section here, we have an active region, right? An active site. and we have a passive one, right? So what it does is when this one fails, this fell over to the passive one. That's why it's active passive, right? So this is what the one that it uses when something goes wrong. Okay? Also, when one moment, please. Can you see me? What's going on here? Okay. One moment.
I see you.
Yeah, I don't know. Oh, I see here. I lost my mouse. I mean, the cursor. I didn't know what it was. Okay, so so in Route 53, you go to the hosted zone and then you create a record, right? So when you create a record, you can choose here the policy, weighted or failover. Okay. So you have the primary here, secondary, primary. And what you do is create a record here, right? And then just put the IP address of the second site or the first site, and then it will fail over when that happens. You can also have some weight here, weight. And in the weight, you can say for this particular IP address, and this is SLC2 instance, right? One is in, by the way, I deleted these guys, right? Because I don't want to have one server in Paris. I created this in the morning class, one server in Sao Paulo and Tokyo, and I usually work on this region all the time, so I may forget about these three. And remember, we only have 750 hours a month. And if you have 4 servers running for 4 days, that's going to be a lot of hours. So you multiply 4 by 24 by 4, and then that's going to go over 750 hours probably in 4 days. So I deleted these guys. So every single IP address is a region, right? This is Sao Paulo region, right? We have the regions here. Or actually, this is a global service. I don't have any. Route 53 is global, so I cannot choose a region. It is global, right? Makes sense, right? But if I have EC2 instances, then I can choose a region, because EC2 instances, it's a region specific service. Route 53 is universal, it's global, right? So you can have an EC2 on every instance, right? So the one that Sao Paulo is in South America, Sao Paulo, right? And I had one in Paris, right? I have one in Tokyo, and I had one in the United States. Okay. So I can just create a failover policy here, but usually it's minimum two regions. If you have 3, it's up to you, but it's minimum two regions for high availability. Okay. So if you want to use weight, the weight policy, which is this one, where is it? I think I lost it. All right, so we have weight. This one, where is weight? Weighted policy. That one, what it does is I want to have this. I want this EC2 instance to get 25% of the traffic. I want this one to get 10% of the traffic. I want this one to get 35% of the traffic, and I want this one to get 25% of the traffic, and that will amount to 100%. So you can weight that, and this is the routing policy that Route 53 uses when you are testing 2 environments, right? You want to send traffic, like we said before, a blue-green deployment. It uses that policy if you want to use Route 53. Okay. So these are some of the additional resources. Embracing failure, fault. Guys, I can send this later, right? I can send this later, this documentation later. I can put it on Slack or here if you want me to. I don't know if you want me to put it here. Okay. So reliability questions. Questions. How are you managing AWS service limits for your account? So you're gonna monitor and manage limits by evaluating your potential usage on AWS. Guys, what do you do when you reach the limits? What do you do? What do you do? Well, first thing before you do anything, you have to know if your limit is hard or soft, right? So if it is soft, what do you do? No answer? Am I alone here?
Increase the usage.
So if it's a soft limit, what do you do if you reach the real limits?
Then you
If there's a soft limit, you can call Amazon to remove it if you want to go above the soft limit. Am I right?
Right. You contact Amazon, AWS, and
Yeah.
then you can increase your limits.
They should remove it, and then you'll be able to go above that soft limit.
Request a limit increase. That's right.
Exactly, yeah.
Increase your regional limits appropriately and allow planned growth in usage. Set up automated monitoring. What is automated monitoring? What's the service? CloudWatch. By implementing tools such as SDKs to alert you when thresholds are being approached. Be aware of fixed service limits that are unchangeable and architect around those. Those are the hard limits, okay? There's slow limits that you cannot increase, so you have to work around that. Okay? How are you planning your network topology on AWS? Use highly available connectivity to AWS with multiple AWS Direct Connect circuits. Remember that AWS Connect it's a private service, right? It's expensive. It doesn't use the internet, but it's also highly available. So you can have several circuits, not only one, right? So if one goes down, you need to have another one. So that's very important. Also, the VPN tunnels, the tunnels for VPN site-to-site connection, you should have more than one, more than one, and minimum should be two, like the same with Direct Connect, right? You can get some appliances from the marketplace. Remember the NAT instance, we got it from the marketplace. The marketplace has a lot of solutions. Okay. Size your IP subnet allocation to be large enough to accommodate future expansion. Remember, we spoke about that when we spoke about VPCs, that always plan to allocate as many IP addresses as possible. Without wasting IP addresses, but you don't want to fall short. Okay, you don't want to fall short. You have to have enough to accommodate future expansion, just in case you want to increment your resources and you need more subnetting, so you will need more IP addresses. So something that you have to consider. Okay, use highly available connectivity to the system with highly available load balancing and proxy DNS-based solution, AWS marketplace appliances. Use non-overlapping IP addresses. Of course, you know that already. We spoke about that with VPC subnetting. You can now use overlapping IP addresses. The system itself will tell you that that's not possible. Okay, and try to use different IP addresses and ranges in and out of the cloud. It's in case of you have a hybrid, in on-premises, try to implement the same strategy. Do you have an escalation path to deal with technical issues? Plan ahead with an ongoing engagement or relationship with AWS support or NPM partner. Use AWS support APIs by integrating them with your internal monitoring and ticketing system. That's something that has to be along with in parallel with your architecture. You have to have plans, strategies, engagement with AWS support. You have to have that, okay? Remember that there's something called elastic load balancer warming, okay? So you have to warm your elastic load balancer. Okay. See, it says here, AWS considers that if the traffic increases more than 50% in less than 5 minutes, then it means that the traffic is sent to the load balancer at a rate that increases faster than the EFB can scale up to meet it. In such cases, one needs to contact AWS to do an operation called pre-warming. Okay, that's very important, and that's what companies do. That's what companies do before a special event, a special day, like a holiday or something. If they think that their load balancer will be under a lot of traffic, what they can do is pre-warm the last load balancer and also create more. Okay, that's very important. What is exactly it says here? I believe adding instances does not suggest a load balancer in case of capacity. Okay. Not always do we find what we need in Stack Overflow. Stack Overflow. But that's something that you need to do, guys. If your you suspect that your load balancer might be under a lot of traffic, or will not be able to cope with the requests and all that, you can either create another elastic load balancer and make it more high available, or you can contact AWS prior to that event and pre-warm your elastic load balancer. Okay. How does your system adapt to changes in demand? Use automated scaling. Nothing new to you guys. From services like Amazon S3, Amazon CloudFront, auto scaling, Amazon DynamoDB, Amazon Elastic Beanstalk. So these guys have, some of them that they have auto scaling built in, like Amazon DB, auto scaling, of course, CloudFront, Amazon S3. They have built in. There's some services that have native auto scaling, and there are services that don't. For example, EC2 doesn't have native auto scaling. You have to create auto scaling and put the instances there. Also RDS doesn't have native auto scaling. When I say auto scaling, I'm talking about high availability, right? As well. So adopt a load testing methodology to measure if scaling activity will meet your application requirements. Like we spoke before, we have to test your system, before things happen. That should be part of your daily routines. How are you monitoring AWS resources? Monitor your applications with Amazon CloudWatch, or you can use third-party tools, right? Configure notification for when significant events occur. What's the service for this? SNS, right? Simple notification service, or Lambda as well. Use automation to take action when failure is detected, and perform frequent reviews of the system based on significant events to evaluate the architecture, right? Next question.
Question on the test.
I'm sorry?
That was a question on a test, that practice test that I did. The previous one, this one.
Oh, the solutions architect?
Yeah.
Okay, there you go. Is the answer here?
Yes. Monitor and automation.
Okay, good for you. So how are you executing change management? Okay, so perform automated change management for deployments and packaging. Okay. Change management. What are the services that we use for change management? The change management. Remember at the beginning of the class?
Mm-hmm.
What are the ones that we mentioned?
Config.
Mention.
It's the config.
We mentioned this one. CloudTrail, AWS config, Amazon CloudWatch, autoscaling. Okay, so those are the best practices. How are you backing up your data? Okay, so backup data that is important with require RPO, recovery point objective. Remember that that's the data that you are willing to lose, right? Amazon S3, Amazon EBS snapshots, third-party software. Okay, I don't know, but I'm not, well, if I'm working in the cloud, I'm not a fan of third-party solutions. If I have my solutions in S3 and all the services in AWS, and it is extremely cheap. So I don't know, it's up to the company, right? You can secure or encrypt your backups. Remember that you can enable server-side encryption in S3. And if the backups are in Glacier, they are already encrypted by default. And remember, a backup is going to be used in the event of the disaster, in case of disaster. If there's no disaster, there are a few instances when you will use a backup, okay? But it's mainly for disaster recovery, okay? If you lose, in the case of your phone, if you back up your information in the cloud, if you have an iPhone, for example, I can't speak for an iPhone because I don't have an Android. Maybe guys, if you have an Android phone, you can speak about that. But you know, Apple has a system that you can back up to the cloud every time you want. If you don't have that, if you lose your phone or you don't have that, then you lost all your data, right?
You can actually back up your phone on an Android as well. As long as you set up the Android with your Gmail, it backs it up into your Gmail.
Good. Okay. To the Gmail. So you have to pay for extra storage in your Gmail?
I don't. I've never had to pay for anything extra. And every time I got in, for example, I have the Android Samsung 7. I've had I have the 9 right now. I had this before, and when I switched over to the 9, since everything was backed up in my Gmail, as soon as I got the new phone and I signed in into my Gmail account, it pulled in all my contacts, my pictures, my everything I had backed up.
Okay. Okay. Yeah, in the iPhone, what it does is partitions everything. Like, this is what you have consumed in gigabytes for your backups. This is for your pictures. This is for email. Okay. So when you get to you're going to reach the maximum of storage, right? So you have to pay for extra. For example, I used to pay like 99 cents every month for 50 gigabytes extra, but for some reason it's not being enough because the backup works, all the data that you consume, it works in your iCloud account. So your iCloud account is being used in your iPhone, is being used in your computer, your laptop, is being used in your iPad, right? So that's all iCloud, right? It gets to a point when you need more storage because you're using several devices with the same account. So now I have to pay like $2.99 for 200 gigabytes. So I had to increase my storage capacity to be able to store everything that I'm backing up with my computer, with my phone, with my iPad, and I don't do any backups with my Apple Watch. But you know, it's I don't know how Android works, but that's the way that Apple works. Okay, so I prefer to use iCloud and not use another. I don't think that you can use a third-party solution with Apple. I don't think they let you do that. But Amazon, you have the opportunity and the choice to back your information up with the third-party software, which I'm not a fan of. But you know, it's just another choice. It's you know, people choose whatever they want. So Amazon just gives you the resources, and then you decide what to do. So automatic backups, you can have either backups that are automatic or manual. Okay. You can use AWS features, solutions for the marketplace, and third-party software. Validate that the backup process implementation meets RTO and RPO through periodic recovery testing. Like I said before, guys, testing, and that implementation works fine. It complies with the RPO and RTO that was originally established, and everything worked well, then we can go ahead and be confident that when that happens, it's gonna fail over okay, and nothing bad's gonna happen. Okay, so user experience, we're not, badly affected. There's gonna be some downtime, but of course, but it's not gonna be that long. Okay, there are some instances when it's less than a minute. Okay, how does your system withstand component failures? Use a load balancer in front of a pool of resources. Hands down, load balancer is a tough guy. Has to be there. Have checks, have checks, have checks. Okay? Working, working, working. That's okay. Traffic to you all the time. Not working, not working. No more traffic to you, and I reroute the traffic to another instance. So that's the way that load balancer works. I'm not sending any more traffic to you because it doesn't make sense. You're not operational. You're not up. You're down. You're off. So what's the point in sending traffic to you? Not sending traffic to you anymore. I report to autoscaling. Well, autoscaling receives autoscaling is constantly sending checks to, and when it says that the elastic load balancer, when it says that the EC2 instances is unhealthy, it will create another one. Then you will register that new instance with the elastic load balancer, and then the elastic load balancer will start sending traffic to that one too. Distribute application across multiple availability zones or regions. Don't forget that if you have an elastic load balancer and then you want to use the elastic load balancer for another region, you have to enable cross-zone load balancing. So that's very important. So use automatic healing capabilities to detect failures and remediate. What is self-healing? What is automatic healing? One instance is not working, it creates a new one. That's healing. That's healing. Okay, that's healing. My system is still running. It's working full capacity. I have one. My desired capacity is 3. I'm gonna have 3 instances all the time. Right? One is down, creates a new one. That's self-healing. Self-healing. Okay. And remember, we treat EC2 instances as stateless. It means that I don't care if it's just broken. I create a new one. That's it. This EC2 instance doesn't have anything special. There's no tracking of state here. So it's down. We have a new one. That's simple. Simple as that. Okay. Simple as that. Remember that autoscaling creates exact replicas of the configuration that we created. Remember, we create first step to create an autoscaling group is create a launch configuration. That's the first step. That's the skeleton of the EC2 instances you're going to create with autoscaling. So it's going to create an exact replica of that configuration. So all the instances are going to be the same, exactly the same. If one goes down, I don't care. I create a new one. That's simple as that. So that's the automatic healing, right? Monitor the health of your system continuously, right? Of course, and configure notification for any significant events. Don't forget that autoscaling is working in conjunction with CloudWatch, right? So CloudWatch is constantly monitoring your EC2 instances, and it will trigger autoscaling if the CPU is up more than the threshold that you established. Then it wants to create one. If it is low than the threshold that you established, if you have a scaling policy, it will scaling and remove a few instances based on the number that you selected originally. So that's how it works. Okay. How are you planning for recovery? Define RTO and RPO objectives. That's something that, like I said before, you have to sit with the architects of the company, because they have architects, right? They have solutions architects. They have, developers, architects. And you have to sit with them because you are the expert in the cloud, right? So you have to define, if we are architecting in the cloud or a hybrid architecture, you somehow involved with the cloud, we have to define how quickly you want to recover, and you want to define how much data are you willing to lose. So that's very important. You have to establish a disaster recovery strategy. Okay, we have repeated this so many times, but that's super important. Avoid configuration drifts by ensuring that AMIs are up to date at the disaster site or region. Okay, what is a drift? A drift is an incompatibility, right? So there's no match. There's no match between the always on site and the standby site. So the AMIs, they have to be updated. They have to be the same, right? They have to have the same so you don't have a drift, right? It's like when you have a CloudFormation template, right? You create resources with CloudFormation, but then someone can go ahead and update the resource from the console. So that's gonna be like a mismatch between the resources that you create, your template, right? Your template with what it says in the console. That will create a drift, right? And I think I show you guys here in CloudFormation. I show you a section that says drift. Right here. Okay. Drift detection enables you to detect whether a stack actual configuration differs or has drifted from its template configuration. Okay, so whatever you created here in the stack, so we have a stack here. This stack is in this template here, right? Of course, this is not right. This is not a normal template, right? This is surfaceless. Okay, so we have a template here, and it may differ from what the actual resource is showing. Okay, that's a drift. Okay, you don't want to create a drift between the two regions. You want the region that is the primary to be in line with whatever is set up in the secondary region. So the secondary site, that's very important. Okay, request an increase of service limits with the DR site to accommodate a failover, right? You know, whenever there's a servicing limit, you have to, if you want to increase the limit, you have to contact AWS and request a limit increase. Regularly test and validate your disaster recovery scenarios to ensure RTO and RPO are met. Test, test, test. Super important. Testing. Testing is what gives you the confidence that something works. You have to validate that. You have to, you know, it has to give you a true value that it works. Okay, that's very important. If something is tested and it doesn't work, it's like you have nothing. Okay, you cannot deliver it, you cannot give it to the user, to the client, because it's not working. Okay, so it has to work. Automate system recovery using AWS and or third-party tools, right? You can automate system recovery, you know, CloudWatch, autoscaling, Route 53, Elastic Load Balancer, you know, all those guys working together. So you can automate your system, you know, and forget about that and simply focus on customer service, right? Review. We've revealed the principles of reliability pillar, discover how to make your infrastructure more reliable, perform an exercise to improve this architecture. We didn't finish the lab, but I more or less show you what you have to do in the lab for those who have not done the lab yet. And we will review some questions and best practice to consider. All right, guys, I want you to tell me, someone tell me what we learned today. Specifics, not this, right? Specifics. What do we learn today? What are the 4 different disaster recovery methods that we saw today? Who can tell me? No one can tell me? Don't forget, guys, that this has been streamed. I want an answer. Okay. Someone, please.
Okay, here it is. Backup and restore.
Good.
So that is either within the network, within the AWS cloud, or using on-premise.
Okay.
Then there's Pilot Lite, where you have a backup system within the AWS cloud that it's not on. It's only on when Route 53 detects that your on-premise environment is down, and that's when the cloud services are on. Then there's a fully working low capacity standby. What that means is you have two environments. One is your on-premise and one is, I'm not sure if it's the same, but similar to what you have on premises, but it's working on low capacity, but it's available. And it requires some time for it to go into what it's called grow capacity, I think it was. Grow. Yeah. And then multi-site active means that you have two sites, one in the cloud and one on premises, that are working at the same time. So you can go between one and the other in case of the on-premises goes down.
And they're working at full capacity.
And they're working at full capacity. Thank you. I forgot to say that.
Very good. Very good. Thank you very much. Thank you very much. Okay. Good. Anything else that we learned today, guys? I'm sure that we saw more things today.
Multi-site recovery.
What can you say about it?
Basically multi-site is just a duplicate of your exact same environment. So that's always monitoring and serving live traffic in a different region in an active configuration.
Okay. Was it you, the one that asked me about passive active one time? Passive active?
No, I don't think
passive?
so. No, I don't think so.
Okay, okay. Because there was someone that asked me at the beginning of the course about passive active, things like that. Okay. So guys, what are the services that we use for foundation? Foundation.
Foundation of what?
The foundations when you're gonna architect and make your system more reliable. What are the system